It's my distinct pleasure to introduce to you Dr. Ho. He's from Kennesaw State University. He's an associate professor and department chair of the computer engineering group. And tonight he's going to speak on artificial intelligence, AI, and some of the trends, the future. And I'm sure there will be a lot of good questions for Dr. Ho. He graduated from BS, MS, and PhD from University of Colorado. Buffalo's, right?
That's right. You got that right.
And he enjoys playing the guitar, and snowboarding, and camping. And he's got a very diverse background in both academia as well as industry. He's worked for Newell, department or division of Rubbermaid, Lockheed, HID, which we all know well, your card. And anyway, so I'm pleased to introduce him to you, Dr. Ho.
Thank you, Phil. Well, good evening, everybody. Can you all hear me back there? Okay, good, great. Well, it's a pleasure to be here tonight. So I was approached by Roger. Where's Roger? Right here? Okay, there you are. To come and join you and give a talk about artificial intelligence. Now, how many of you have heard of artificial intelligence? Okay, so you'd be pretty awkward if you haven't heard about it, right? And I understand this is all professional engineers group, or most of you are?
99%.
9? Can I get to know you a little bit? How many of you are civil? Civil. Okay, wow. Huh? We're starting with the discipline. How many of you are electrical? Wow. It's quite a few. Mechanical? Okay. And software, how about software? You got a friend back there. You got 2 software. Okay, great. Well, as you know, artificial intelligence is not just a hype. It's not hype or buzzword, although it may seem to be because you hear about it everywhere. But think about it this way, or consider this. In the next 20 years, you will experience and see changes in the way you work, the way you play, that is equivalent to the last 2,000 years. Okay? And you might find that hard to believe, but let's take a look at the historical perspective, if you will. Back, let's see.
One more time.
One more time? Okay. Sorry, this diagram is a little bit small, but what it's depicting there is that long time ago, we started out in the hunter and gatherer era, right, where our daily life was all about hunting and gathering food, and that lasted for several million years. Okay, back in the caveman days and so on. And then after that, we advanced to the agriculture era, where we learned how to farm. We learned how to farm and produce food in a more volume and convenient way to feed a bigger community. So that agriculture era lasted several thousand years. Okay? And then after that, we invented the steam engine and electricity. And hence, we got into the industrial revolution. Okay? And that lasted for a couple hundred years. Right? So you see the pattern? And then what's next? Next was the information age, information era. So that's when we invented the transistor. And then computers.
Stay over there, please.
Oh, so you can get the recording?
We want to watch you.
It's very hard for me to stay in one place.
I know.
I'll try to do that, but I'm going to step away from time to time. So the information age is all about computers and your devices, your smartphones, and so on. But that era is about to transition into the next era that we're at the cusp of experiencing. And there's many terms for that, for this next era. But one of the terms is called the augmented era, the augmented age. Okay? If you haven't heard about it, don't be too concerned, because it's a newly coined term. But basically what it is that we will use machine to help us think and do work. Okay, help us in a more cognitive way, not just executing tasks, but help us in a creative way. Okay? And all that is going to be enabled by artificial intelligence. How long is that going to last? It's probably going to be shorter than several decades. Okay? So the person who coined the term here is by the name of Maurice Conti. He's a futurist. He works at one of the biggest moonshot factory where they do outlandish projects and innovations and ideas. So the idea of augmented age is if you tell the computer, hey computer, let's design a car, it will design your car. Okay? And then you can tweak it, you can say make it bigger, make it smaller, make it faster, whatever, it will do that. So computers have the ability to think and do the work and do the thinking for you. And hence the augmented age. Okay? So in his own words, over the course of the next 20 years, there will be more changes than the last 2,000 years in terms of the way you work and the way you play, the way you live. All right? Okay, so let's go through the basic real quick. What is AI? So we heard a lot about AI, but anybody have a cool, easy understand definition of AI, artificial intelligence? And a notion? Yes, sir.
Developing a large database of actions, memorizing that, and then doing design based on that database.
Database. Okay, it's one definition, although it's a little bit technical because a lot of people might not know what database is. Sir, what about you?
Self-learning program.
A self-learning program. That's also correct. So we're getting warmer. But the way that I think about AI is try to be very intuitive. Is that you develop machines to think, act, and interact just like humans. Okay? You want machines to be able, on your behalf, to think and act. Okay? But in a rational manner, not in a out-of-control world domination manner, which is a concern for a lot of people. Right? I can see some of you smiling because, yeah, you probably can relate to that. Okay? So, what does it mean by think and act and interact like humans? Well, three basic components. First of all, you got to get machines to be able to speak and understand languages. Okay? And a lot of you, believe it or not, have already experienced the applications of speech processing. Take a look at Siri, Alexa, right? Google Assistant. You know, you go in your car, you say, hey, car, drive me to the Target store, and then it'll do all of that for you. So that is based on the speech processing technology. It understands words and speech. The second component of machine intelligence is image perception. So the machine's got to be able to see, just like you. Not only see, but recognize what's what. Right? Whether it's a snapshot or a real-time video type of information, machine got to be able to perceive. Okay? And then the third major component is think. The machine got to be able to process all that information and decide what is the best course of action. What is the best action based on the objective that you have. See what I'm saying? And learn from its mistake. Learn from the practices and become better, just like us humans. So if you can make a machine that can do all these three, they can get closer and closer to our own ability. In fact, in some cases, they can be better than us because machines are faster. They don't get tired, right? And they can work in and out all day long.
Don't get drunk.
They don't get drunk, that's right. They don't get emotional either.
Hopefully
Okay?
no psychosis.
That's right. We got to ensure of that. We got to ensure that.
Is there going to be a heaven or hell for machines?
Heaven and hell? Now that's a deeper question that the moral ethics want to get into, right? Will robots have moral standard? Will they act on moral standard, or could they get out of control? Okay. So speaking of that, there's three views of artificial intelligence. The first is the optimistic view, from an optimist. Okay, like this gentleman here, Sergey Brin. He's the founder, the co-founder of Google. So he looks at it very optimistically. You know, AI is most significant development in his lifetime. And every month there's stunning new applications that come to life. And that's very true. If you follow AI, new applications and breakthroughs are happening on a weekly basis, if not daily. Very fascinating. And that's why it compelled me to be the curator, be the educator of artificial intelligence, because for engineers like yourself and for our university students, if they don't know as much as they should know about AI, they will be very obsolete very soon. Okay? With the rate that AI is affecting our industry and our design development, we got to know what it is and how to apply it. So that's the optimist. Oh, sorry, you can't read that, huh? So here's a quote by Stephen Hawking, and I'll read it to you. It says, "The development of full AI could spell the end of the human race." Okay? So the late Stephen Hawking, that's his point of view, is that AI, hey, just like nuclear weapons, for example, or similar to nuclear weapons, in the wrong hands, if not protected, it could do a lot of damage. Okay, it can bring to the end of human race. Yes?
He wasn't an optimist.
No, not Stephen Hawking. Yes?
Didn't Google turn off a couple computers they developed last summer, or they had to turn them off because they developed their own language?
Yes. We can talk a little bit about that. There are computers that, it's Google, Facebook, Microsoft, they all have done it, that they launch into the field to interact and talk to people outside as well as talk to themselves. And they've gotten to a point where they become hostile. Okay, I'll take an example like Microsoft. Last year, I think, or 2 years ago, Microsoft launched this character called Tay on is it Instagram, something like some social media, and the character interacted with audiences and people out in the outside world, and the character it started to express some really hostile, racist comments, and Microsoft had to shut it down immediately, and it was based on the character's interaction with the people that he interacted with. So it could get out of control. So thank you for bringing that up.
How's Chill doing?
Huh?
How's Chill doing?
Chill?
Did she change?
Chill? Who's Chill?
Georgia Tech,
Oh, Georgia Tech.
the technical assistant.
Oh, okay. I've been following that.
The TA,
Yeah, the technical assistant, yeah.
Oh, okay. The tutoring.
Yeah, the tutor.
Yes, I heard great things about it. Is that she's become so effective that is,
You had about 3 years with, I think, now.
yeah. It's replaceable with human tutors, which is pretty amazing. So you have the optimistic view and you have the pessimistic view. How many of you use Alexa or Siri pretty regularly? Okay. So then there's a perverted view, which says, Alexa, she's always ready for action. The perfect woman never says not tonight, dear. Okay. Now there's probably a deeper meaning, insinuation about that, if you know what I mean, right? Technology can get into dark places. But so those are 3 different views. I'll skip this. Just a little bit about the industry itself. In a couple years, it's going to become a huge industry, you know, in the amount of hundreds of $billion industry. Okay, so it's going to drive our economy. AI technologies and application will drive our economy. And as engineers like yourself, it's going to affect your job. Okay, if you want to keep up your ability to earn, to be relevant, you gotta be able to keep up with AI and understand how that affects your job and your industry. Okay, why? Because up to 47% of jobs, based on some studies, will disappear in the next 25 years. Or another way to think about it, 20-something% of jobs will disappear in the next 10 years. Jobs like customer service, truck drivers, Uber drivers, even engineers. Okay, computers will be able to develop code, develop software, will be able to design bridges. Okay, so you got to think about, okay, well then, how does that going to play into my own career as an engineer, or any kind of profession you might be in? So this is real. It is a concern to a point where some legislators are talking about taxing robots. So factories that are going to use robots to do the work have to be taxed on that, to take some of that tax revenue to help develop and repurpose folks that are displaced, for example. Okay, so this is one of the downside of technology. Okay, and so I'm going to show you a sprinkle of different videos of AI technology. So this first one is a robot designed by a company called Boston Dynamics, which some of you may have heard of, which is one of the Google companies, and they're probably one of the world's most advanced robot companies. So what you're about to see here is this robot here, which is emulating a human being, and he's going to do some backflip, okay? But you see how he learns from it as well. It's pretty fascinating, so check this out. Oops. So here's doing when he learns, and watch this landing. It's not always solid. That was a pretty good landing. Watch this second landing. A little bit shaky, but he learned from that, just like you would as a human. And then of course, he falls like you do too.
Amazing.
So think about it. The amount of technology in the motors, in the mechanical parts, in the coordination of all the movement, in the software and all that is very complex.
How long
But
ago was that made?
this is probably a year ago.
Obsolete now.
Yes. If you take a look at their latest robots, I mean, they can jump and flip and do gymnastic stuff, and not just backflip like we.
strings.
Huh?
And no strings.
No strings? Oh yeah.
No strings.
So here's a funny story. This guy designed a robot at first to help him clean the house, and he later married her. True story. They had the ceremony and they go through the whole process. True story. Show you the downside of
Got what he deserved.
Okay, take a look at this picture. Tell me which one you think is real. Sorry, the projection isn't as good as what I see on the screen. But which image of this human face is real and which one is fake? How many think this one is real?
Left one looks real.
How many think this one is real? So most of you think this one is real and this one is fake?
They're both real. They're both fake.
They're both fake. Oh, you got no faith in technology. Actually, this one is fake. I'm sorry. This one is real. This one is fake. Yeah. So recently there's a branch of AI called generative adversarial network that can generate hyper real images and videos of humans and animals or whatever that you like to generate. So it can look. So take a look at this picture. It looks as real as it can get, right? Almost as if there's a soul behind this person. That's amazing. I mean, if you look at it, you would not guess that it's computer generated, but it is. Okay. So we have the ability to generate images like this. Now here's the scary part. Furthermore, late last year, a company called NVIDIA developed a technology where they can blend two faces together. Okay, they can take, for example, like fill your hair and your face and match with Steve's nose and eyes into a new person. Okay, specifically, they can mix and match facial features together to generate new image. In fact, I have an example right here. This example here is that this person takes on the facial shape and the hairstyle of these people up here. Okay? For example, take a look at this generated picture. So she took on the hairstyle of this person, right? And the facial shape, the pose of this person to become a new person. Okay? So now what application that may result, there's probably a lot, but it's too soon to to see any real world application at this point. So this is a technological development. Oh, sorry, you can't read this. I'll skip this slide. So this is more closer to Earth. This is something that you see every day now. You're experiencing all the Google Assistant devices and all the Amazon Alexa devices, okay? Those are smart devices that are connected to the internet as well as understand your needs verbally, okay? You can say, hey Google, what is the translation of I want to go to lunch in Spanish? And it'll understand you and it'll translate that for you, okay? Or hey Alexa, turn off the TV, and it will do that, okay? And you can and you can have a strong accent and it'll still understand you. So the technology is so advanced that it's highly accurate. It makes it very practical to use. So I'm going to show you another example. I'll skip this. This next example is a demonstration of an interactive machine that that calls in for reservation. Like if any of you were to call in and make a restaurant reservation, you have to adapt to the conversation, right? You can call the host and say, hey, I want to pay table for 8. She said, oh, we don't have a table available for 8, but maybe for 6 we'll take it. No, that won't do it, so I'm going to have to call somebody else, blah, 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 right? So you have to adapt to the conversation. Well, Google just launched last year a Google Duplex, which is a machine reservationist. They do the job. So watch the following.
Even in the US, 60% of small businesses don't have an online booking system set up.
He's
So
a
what
Google
you're
founder,
going to hear
CEO.
is the Google Assistant actually calling a real salon to schedule an appointment for you. Let's listen.
Here's the robot right here.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. Okay, we have at 10 o'clock. 10 a.m. is fine. Perfect, so I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day, bye.
This lady have an accent.
How may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next
Night?
Wednesday at 6 p.m.
Oh, actually we need to for like after 5 people. For people you can come.
How long is the wait usually to be seated?
For when tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. It's you can come okay?
Oh, I gotcha. Thanks.
So you can see that the robot was very patient, very rational, despite the lady was, had an accent and has a language limitation. But the chatbot is what we call them. Chatbots are robots that does the talking. But he worked through that. Okay, so another area of development in AI are robots in terms of pet bots, which are more and more used as in the homes for companionship. So you have pets that are used for companionship. So a couple months ago, in January, I attended the CES Consumer Electronics Show. Y'all heard of that? Any of you heard of that? It's like the biggest show on earth in Las Vegas. Like tens of thousands. I think like 120,000 people showed up there.
It's just shy of 200 this year.
Really? Okay, so more than I thought.
180, 185. Yeah.
Yes. So I went to this booth, Sony, and I saw this eyeball robot, and I learned more about it in terms of how does it exhibit personality and intelligence. So the lady who worked there told me, well, you got to pet it, and you got to talk to it, and develop that connection, and after a while, it recognizes your intent and gesture, and then it'll interact with you more and more. So I went to the table, I petted, and said, eyeball, how you doing? And you feeling okay? And And after a while, he'll look up to me and gaze me, with his puppy eyes, and yeah, that's more like it. I can feel the affection, the interaction. That was great. They made it very, very almost like a real pet. And then at that moment, this young, attractive woman came up next to me, and Ibo immediately ran over to her. And I was in despair. I said, "Wait a minute, what's going on?" Right? And I spent the last 10 minutes befriending him, and then the lady came in and he went over there. So I scratched my head, and then I was talking to this girl, and then I realized that she was here before I came, and she befriended him even more than I did. So when she came, he recognized her voice and her visual, and boom, he went to her. So I was okay after that. All right.
The machine before training.
So the next one that I'm going to show you is how many of you have heard of Space Invaders game? Okay, a lot of you probably back in the days, right? When our arcade game just came out, Space Invader was one of the most popular. I mean, today it's still the classic. Anyway, just like chess and Go and all these games that we've proven to outperform world champions. So here's an easy example where they take a machine and train the machine to play Space Invader completely on its own. No human intervention. It's not like the human goes, okay, you move to the right and left and do this, do that. None of that. Okay? The machine learns when it fails. When it got bombed, it learned, don't do that again. Okay? So the learning algorithm in there shows that's how you should learn and what to avoid, what not to avoid. And so what you're going to see is an explanation of like 8 hours of training a machine to play Space Invaders, and watch what happens.
Is the machine before training. So this is literally the first time the machine has ever seen this data stream, and it's controlling the green rocket here, and you can see it's losing its 3 lives immediately. So it's basically terrible at the game, as you would expect. Now after training, this is like overnight, we leave it playing the game overnight on a normal computer, so for about 8 hours. You come back in the morning, and now it's superhuman level. So now the machine can play Space Invaders better than any human can. It's modeled the world, the game world so well, it knows where the Space Invaders will be ahead of time. So as the Space Invaders speed up, when you get less of them on the screen, it does fires the final shot as a kind of predictive shot of where the final Space Invader will be.
So think about it. I mean, can you learn how to play Space Invader that well in 8 hours? No way, right? So that's the advantage that machines have. Not only that they can learn and train, but they can surpass our level of performance. Right? In fact, even in image recognition, recognizing images of people, we got to a point now where machines can recognize people and images better, more accurate than we can. Right? Like if you see your friend in a crowd of people, you may or may not be able to recognize or detect them. A machine can probably do that better than you. Okay? It's pretty amazing. Yes, sir?
Why not, if you're a learning type software program, go straight to the program of the game rather than what we would see? In other words, it goes straight to the zeros and ones. Says, what's the pattern here?
That would probably be a form of learning that may or may not be effective. But the form of learning that's used in here is called deep learning, where it doesn't go down to the ones and zeros, but they look at it at a higher level. They look at it from the results.
Yeah, I understand what you're saying, but I'm just saying, if you're a really smart computer, you go after its program. Once you got its program, you know what it's going to do.
That's a possibility. Yeah, you never know. Yes, sir.
So in the example there is in Space Invaders, where you have the machine that's got the ability to learn, what if both machines have the ability to learn and they...
Oh, yeah. Now that can get really wild. Okay.
Learning.
So there's been cases like that. You all heard of the Go game board that Google beat the world champion? I think that was in 2010 or so. So 10 months later, Go, the computer, the AlphaGo, which is the name of the computer that beat the world champion. Okay. 10 months later, AlphaZero trained his sibling called AlphaZero, completely working with each other. no human intervention. And AlphaZero, the sibling, beat AlphaGo 10 to 0.
Wow.
So, I mean, how much they can get better is it's just mind-boggling, right? So here you got a computer that beats a world champion, and then you got another computer that it trained that outperformed it 10 to 0, hands down every single time. So the notion of machine training machine is very powerful, and that's happening. Okay, we get to a point where we let machine train each other. In fact, Facebook just recently have been experimenting with getting their machines to talk to each other and learn how to negotiate and discuss whatever they discuss. And they got to a point now, I don't have the image to share with you, but they got to a point where they talk to each other in a language that we don't understand. So they figure out certain protocol to talk to each other, and we don't know if that's a productive discussion, conversation or not, but they're doing something. And therein lies the concern about machine going off to a space and doing things that we might not comprehend enough to detect danger, right? To detect what may be consequential as a result of that. Yes?
Now in Space Invaders, does it accomplish that by memorizing each and every combination so that when a combination comes up, it then duplicates that combination that's solved before?
Yeah, but not in a rule-based like you may think, not like an if and else. It's just like how you would play a game. Okay? Yeah, there's certain strategy and certain pattern that you follow, but it all depends on the environment and all the variables and the whole situation. But you don't make decision in a explicit if and else. And that's how machine function and work. In fact, it's called neural networks, which I'll show you what it is exactly in a little bit. It's very different. Let's put it that way. Okay, but keep that word in mind. Neural networks. That is like the core of machine learning that's driving all of these breakthroughs. Okay? So the next one I'm going to show you is vision detection. So this here is a machine, say if you're driving down the road, just like autonomous car, you have a camera. Well, we have the technology today where the camera can identify everything that it sees in its preview. Right? Just like you. You see a dog, you see a person walking, you see a traffic light, you see a pothole. You can classify what these objects are. Well, machine can do that. Okay, so watch this example. So it's identifying other potholes. See the square images are showing you what it's detecting. And now it's detecting people. I wish I could stop it, but see that? People, motorcycle, cars, it can detect and classify everything that's in front of it. Okay? Huh? Cows? Yes. Animals? It would have to, in order for it to be reliable and safe.
Is that cow or CCW? I can't read it.
This here? Car. C-A-R.
Oh.
Yes.
So what kind of range will that work at?
What kind of range? You mean like depth?
Stand out and walk down the road.
What distance you have to have, to recognize?
I don't know. It has to be a range that is workable in terms of that give you enough time to make decisions.
That would work with a missile out 20 miles.
Then they have to design it for that range. If the target range and the operating range is further out, then the algorithm needs to be trained and target that further range. So you can't take this exact algorithm and use it for missile tracking or identification. You have to get it to learn. You have to feed examples. Hey, if you were to see missile flying by, you give it thousands of examples. And then just like humans, you say, okay, I get it. Okay, that's the image, that's the range, and then it starts to become useful for you. Okay? So it's not a generic algorithm that works for any.
This took quite a bit of training for the machine to recognize all the different examples.
Yes.
All the different objects
Yeah.
count.
Tomahawk cruise missiles have a more rudimentary version of that.
I'm sure there is. Yeah. Oh yeah.
Following, not that sophisticated though.
Ah. Okay. Yes.
Tesla had a problem, right? They thought they could identify everything, and they got fooled, and there was an accident.
Sure. And therein lies another big topic of discussion, is that you all are seeing autonomous cars being launched, right? So how comfortable are you to get in a car and hands off, go drive, take me to places? How many of you are comfortable letting a car completely drive for you? Not many?
Well, defined completely.
Not yet?
Under
Okay.
human supervision, yes.
In a restricted area, no problem.
Okay.
Ironically, in the news today, there was a news article about a Tesla that stopped for a rabbit that was running across the road.
So, just like with any technology, it's going to take some time to work out the kinks. So the fact that Tesla had an accident recently, a couple months ago, right?
It changes every day.
It's part of the process. It's not going to launch and be perfectly reliable. That's not going to happen. But if you look at it relatively, if you look at the rate of accident compared to what humans undergo, right? It's still significantly less, the rate of accident. Okay? Significant. Just like if you fly in an airplane, we've flown in airplanes for so long now, we've accepted and appreciate the lower rate of accident of airplane compared to cars. But yet we feel equally comfortable whether we're in a car in an airplane.
Seatbelts have a similar history.
Yeah.
They were introduced, people were reluctant to use them.
Yeah.
They did not particularly trust them. What if the car catches fire?
Yeah.
Yeah.
So it would take time for people to assimilate
My Honda is also able to spot the speed speedometer or speed signs and post it on the car inside. The last sign I saw.
Really?
And it also slows down with radar and the vision to match speed of the car. Up to complete stop, and then start up again.
Okay, so is that a new Honda, recent Honda that you got?
2019 car.
Yeah, there you go. Yeah, they're starting to use these technologies. Yes, sir.
Have you seen any of the Mercedes hauling trucks where they test them in Germany to drive by themselves?
Yeah. In fact, another example is Uber. Uber is very big on autonomous cars. They have been using autonomous trucks to deliver beer. So they deliver 5,000 cases of beer. According to Uber. So, yes. But autonomous cars is there's a huge downside, as you can imagine, that we have a very huge truck driver industry that are in tens of billions of dollars industry. So eventually those people will be displaced because of autonomous trucks. So we have, as legislators and as technologists, we have to figure out how to offset that. Yes.
Another professor discussed AI with trucks traveling in caravans, and they'd be on the same pathway. Now they'd be running right after one another, that you can't merge or cross over to get past in or out of the traffic with them.
Platooning.
Plus they're running on the same spot on the road and wearing the road down because they're training right behind one another.
Yeah, I'm sure those concerns are factoring into the design of autonomous trucks, such that they are not unfriendly with human cars and human drivers. I'm sure those are factored in. So I wouldn't worry too much about that kind of effect. Okay?
Question over there.
Yes.
In the dark ages, we burned books. From what I gather is going now is there's no need for books. My question is, how are we going to archive things electronically without power? We're going to become so dependent on power that if we have all our knowledge in electronics, we have no knowledge of our own.
You mean power like power? Electric power? So why would that go away?
Well, my grandson just graduated from tech. I offered him all my tech books from 57.
Yeah.
Mother Nature hasn't changed. He never wanted my textbooks because he got it all on this little.
Oh, okay. So it's all in digital form.
It's all digital. That's what I'm saying. It's all digital.
Yeah.
And it's not being hard copy to the
Oh, yeah.
If we lose power, we lose knowledge.
Oh, so
We're gaining all this knowledge, but it all goes back to what we know ourselves in the brain.
and that's another moral question that we have to confront.
I think we need to be looking at the overall effect. We're burning the books.
I agree. Yes, sir.
Dr. Ho, don't you think, I'm going to talk philosophically a little bit here, the transition from, the industrial age to the modern age to every leap, there's always a quantum leap in technology, especially the horse and buggy to the Model T. Everybody thought, oh my God, the world's coming to an end. But I think at least from what I see, the quantum leap that we're going to augmented reality or artificial intelligence, is the quantum leap is so high that the transition, if you're not willing to jump into that in coding and so forth, I think that's what the biggest fear is. Is that big jump instead of the normal just gradual migration.
That speed of change.
There's no jobs for us that we get.
Well, I know, but I'm a millennial. Okay, I'm a baby boomer with millennial tendencies and traits. So what that means is I'm 29, but in order to stay competitive, I have to go back and learn React and Python and PyTorch and all these new technologies.
There you go.
Relevant, okay. So in order to do that, it's a whole different learning set.
And think about people who had to adapt to computers when computers came out.
Exactly.
And a lot of people choose not to learn computers. And you can see that that's the compromise that they're going to face, is that they're going to be further away from the mainstream.
There's the saying that you either create the wave, ride the wave, or get crushed by the wave. And I think we're at that point where no matter what age you are, if you don't at least grab a hold a little bit of the wave, you're going to end up being so far behind, and it gets into that horse and buggy thing.
And that's my point too, is that we should adapt and learn the technology if we don't want to be crushed or be left behind. Think about this device that you all love dearly. Right? This has only been around, the smartphones, for what, 7-8 years? So life 8 years ago is different from now. But can you see how it transformed the way we live and the way we work? Now the next 8 years is gonna be obsolete.
It's already obsolete.
It's already obsolete or becoming obsolete.
No, that one's obsolete.
This model?
They come out every week with a new one.
Yes. Okay. All right. Yes.
I just have a comment to what you said. There's a metaphor when they talk about innovation. They talk about the S curve.
Right.
You get the most of the S curve, and you change to the next S curve for more innovation. Not as opposed to staying in one way. You know there's going to be something coming down the pipe that is more productive, more efficient, more effective. You just got to know. The person who suffers is the person who doesn't take the risk to change S curve.
And it's like we're looking at augmented reality and VR and all that. That's the next big wave too. As well as artificial.
I think the key point is that we need to prepare for the transition, right? So the learning curve, the integration, all of that, or else we will accept being left out or being compromised, because that's where society.
I think Neuromancer predicted it. The next step is jacking into the network. Is in right here.
With a chip.
You've read Neuromancer. The William, what was his name? Predicted the internet. Have you read it?
No, not that book.
Gibson, William Gibson. William Gibson's book predicted every bit of this.
So what are the uses of AI in fighting cybercrime?
Cybercrime.
Or is it going to be AI versus AI and commit cybercrime?
I bet you there are projects out there that uses AI, because that's a very good area for AI to really go in and deep learn what's going on all over the world, all corner of computer networks.
Again, we already have rudimentary versions of that. There are learning firewalls that look for certain sequences, and if so, it'll automatically block. Again, nothing the level of sophistication.
Take a look at a more mundane everyday example. We use AI to detect and filter out spams in our emails.
That's a good example.
You know how many spams get sent to you every day, like in your Yahoo or Gmail inbox? More than you know. Okay? But the system kicked them out, put them in the junk box that you don't know of, but it's been very effective in doing all of that.
We could take our ideas.
So how much time do I have?
As much as you want.
About 20 minutes.
No, 20 minutes.
About 20 minutes? Really? Oh, I thought I had to. Okay. Let me show you a next example. This is more of a creative nature of AI. Okay? Now this is where that augmented cognition comes into place, where we use machines to help us create, to help us design, and not just do tasks. Okay? Meaning help us create music, help us create art, help us do design, things like that. They're capable. So this next example is a tool that help you create a painting, if you will, of a landscape, okay? Without really doing much of the work, but at a high level, you say, okay, I want to put a lake here, I want to put some mountains here, I want to have some trees here, right? You have that notion, and the computer will go and render the various different images that may fit what you envision, okay?
We could take our ideas and turn them into compelling images. This technology allows us to create a smart paintbrush so that if you wanted to create a new picture, you can just draw the shapes of the objects that you want, and the neural network can then fill in all the details. If we add a water feature, the network is able to add reflections, not because we told it that, but because it learned it. Or if we change the ground to be covered in snow, then it knows that the sky also needs to be a different color.
So, you know, I don't know about the rest of you, but I have artist aspiration. You know, I love to draw, not love, but I aspire to create nice drawing and paintings, but I can never draw, right? But I have that creative part of me where I would recognize a landscape or a painting and appreciate it, or I love to create it, but this kind of tool will help me translate that high-level notion that I have into something that is visually satisfying. Okay, you can do the same thing with music. In fact, there's a hit right now called shoot, I forgot the name, but it's number 6 on the Billboard. It was created with the help of IBM Watson. Created a hit song. God, the name of the song is on the tip of my tongue, but I don't remember. So, in a couple of years, you can expect to see books, even Pulitzer Prize books that are created, that are composed by machines. And the way they do that, folks, is that it just doesn't do it magically, do that one day. What you do is you feed the machines all these images of lakes and mountains and sun and trees and thousand, and it learns from those images, right? The different configuration, the different positioning of trees and lakes and mountains, and over time it knows what a nice picture look like. And then when you tell it to put a mountain behind here, it knows what it's supposed to look like and create that for you.
Can you help bridge the abstract from the laboratory mad scientist to the common man? How is he going to use this as a tool? It's physically out there. How is Joe Blow going to use AI?
Okay. So let's talk about a few real-world applications. Okay. First of all, let's take a look at medical diagnosis. Okay. You go and you take your X-rays or pathology reports, and what do doctors do? They sit there and they painstakingly go through and trying to diagnose whether you have certain ailment or cancer or not. Okay. Now we can train machines with all these different photos and pathology reports and information and so on, that over time it learned how to make diagnosis on its own or assist the doctor, so that doctors can not only do more volume of diagnosis, but can do it more accurately.
Okay. I mean, one of the hardest things, almost as big as AI, is we can go to the nano level and see somebody's chromosome.
Yes.
They can change it.
Yeah.
Okay.
Yeah.
So you take a sample of this guy's blood and you can find out if he's likely to get cancer.
Yeah.
You got to bridge it to the 370 Americans, you know.
Yeah.
20 years from now, 10 years from now, how are they going to use AI?
Okay. So medical So stay on the medical topic. So today, we have the technology to make diagnosis equally accurate, if not more, than doctors. Okay, and that's the first benefit that you see. I'll take an example. Just last week, MIT announced their system able to diagnose breast cancer that are 5 years pre-cancer stage. Okay? Prior to this, doctors have the ability to make that prediction, but only Caucasian women, they can do that. But for women of color, the guidelines don't work. So they miss out on this benefit. So this AI machine came along and was able to learn and develop the ability to predict advanced cancer development for both Caucasian women and women of color. Okay? So in terms of those capabilities, they are in use today. 10 years from now, the projection is AI will be able to help cure cancer, not just diagnose. Okay? So in the medical field, that's one example. An everyday example is like you all watch YouTube? Anybody? So
We have a YouTube channel.
you do? Okay. So, I've come to be a YouTube watcher nowadays, which is, I shamefully admit, I watch more TV than I used to. Because when I sit down and I turn on YouTube, the recommendation system is so accurate. It presents to me the menu, the options of all the clips and videos I happen to like. Whether it's sports or about technology, all of a sudden it just goes and finds all of this. And it uses AI technology to understand my needs, my desire, as well as people that are similar to me, that I have no idea who they are. There could be thousands of people out there that likes technology, that likes music, and blah, blah, blah. And it infers from those people's likes and dislikes and so on to come up with recommendations for me. So that is happening to us every day. Netflix, Spotify, Facebook, Amazon, you name it, they're there.
Also the commercials you get.
Was that?
Also the commercials you get.
Commercial, that's right.
What you say to your life.
So there's a lot of products that AI is helping to create.
Yeah.
Those are really useful. But are the tools to use AI to create products becoming more accessible, or do you still need a computer science degree? And,
That is the biggest barrier right now, because to use AI, even like for me, to create a machine to learn certain set of images, for example, I would have to get into the Python coding and understand some of the nuances to do that. So the industry recognized that this is not going to be accessible for non-engineering folks, if you will. So Microsoft last week, believe it or not, announced a tool where you can go and create a machine, a learning machine, without a line of code. It's like have y'all ever designed a website but just click and drag, right? Right. When it started out, you have to do HTML programming, right? And then over time, they made it such that it's GUI driven. You just click and drag the menu, and you can create a very nice website. That's where we're heading, okay? To accommodate folks that are not techie, like marketing or sales folks that want to process their data and so on. There'll be the engineering type that wants to get under the hood to say, I want to tweak the algorithm this way, add some more layers and add different activation functions, so on and so forth. Okay? Yes?
I'm not saying it's adversarial. I'm asking you, you're the professor.
Yeah.
Is it going to be collaborative, our children, our grandchildren? You can be pessimistic and say, okay, United States versus China and India and the Asian nations. Are they going to surpass us and we're not going to be competitive as a nation? What is the outlook for our children, our grandchildren? Are they collaborating globally? Is globalization? Where are we going with AI? Are we going to be in the field or are we going to use technology that other countries develop?
That's a very good question. So where do we stand relative to other countries, and do we collaborate with them, or will we collaborate with them? I think the answer is a little bit of both. For example, every country is pushing ahead with their own resources as well as collaboration, but China and U.S. in particular are competing to lead AI. In fact, China has announced that by 2020, they are going to be comparable to US in terms of AI technology. They're going to be comparable to us. And they also announced their goal that by 2030, they will be the leader in AI. Recently, you heard Trump with the initiative of AI initiative, right? Where we're putting money in to develop AI technology. So everybody's competing. Now, underneath all of this,
How are we competing?
How are we competing?
What is our strategy?
What is our strategy? Well,
Do it for us.
our strategy is that we invest in government projects like what the AI initiative that Trump just announced. We empower our industry like the Google, the Facebook, the Tesla, to go and develop the technology and use the technology and have legislation to support.
I asked that question because that's what was said about Japan.
Yeah.
The same thing that you just said was said, the guy who was heading the dean of the Sloan School, he wrote the book, and it was 3 markets. It was the Japanese market, it was the American market, and the European market. And one of his premises was that one of those 3 groups that was going to dominate was the one who excelled in these different fields. He was pretty close. So, yeah, we can have that China, but that 3 times as many people as we have. So how, we got to have something to compete, a strategy.
Well, traditionally, we have the R&D talent and capability, traditionally speaking, right? Many of the innovations and invention that were developed in the U.S. are very major development. But other countries like China is catching up. In fact, I can tell you that their strategy, an advantage that they have, is they have a lesser burden of privacy data. For example, in China, you can walk into a store anywhere and there's camera watching you, recording that all information, and they get sent to the database and to the government. And they can machine learning is all about data. It learns from data. But over there, the government allowed data to be used that they can obtain from your daily life. Over here, right? We do something wrong, boom. You got folks that are going to scream bloody murder, not having their consent to get your picture and your information, your application, and so on. So China appear to have the advantage of having more access to data. Okay, and that's the fuel to AI development.
You don't have to worry about privacy.
Yes, they don't have they don't, because the way the government works over there, the government have more control and say of privacy. Yes, sir.
Looks to me like it would be a function of brain power. Who has the best brains?
That's right.
How are we securing that for our country?
We do that by promoting our university, promoting the technology from the industry to attract talent to stay within the U.S. and develop in the U.S. But remember, other countries are doing the same. They are cultivating their talent as well. So,
are we being robbed of that? They send them over here, we train them to go back?
There's some of that. There's some of that. But that gets into the balance of collaboration. Right? We can't say that we want to collaborate with other countries, but yet be so protectionist. It's a balance. And that's where it gets dicey and touchy.
And by the way, the song you wanted was Not Easy.
Yeah.
Not easy, yes.
I just
Thank you.
found it too.
Yes.
I'm also concerned about the ethics. And like I saw the robotic dog.
Yeah.
And I'm saying, gee, there are dogs in shelters that need homes. And, they're a lot less expensive than the robotic dog. And, so that I think unless the ethics is tied to everything else, including watching international traffic to make sure that our intellectual property is not being stolen and it's not being used against the United States, it's not being used to enslave people, perhaps for child sex trafficking, unless we have the ethics piece across the universe, we have problems.
You're right. I mean, that's That's a concern that many people have raised, the morals and the ethics behind technology. How can we ensure that the technology doesn't get out of hand? Yeah.
Ultimately, 5 minutes.
Man creates a machine, so now machine is going to control man.
That's right. That's the other concern. Okay, yes, sir. Yes, sir.
That's been going on since the beginning of mankind. I mean, the Nobel Prize was a guilt trip because of discovering dynamite. And now we have the big issue on the tariffs is due to the allegedly stolen technology, a requirement to transfer technology to China. I had no idea until listening to you talk how big a deal that is. Right?
Yeah.
Excuse me, can we let you finish the presentation, because we've only got about 5 minutes.
Okay, all right. Thank you. Great questions, ladies and gentlemen. These are questions that would take a lot more in-depth discussion to really appreciate the various thinking, but I appreciate you raising the question. Now, I don't know if you care to get into the technical aspect, or do you want to see more examples? Technical? Okay. Yeah, that's right. You're all engineers, right? So shouldn't ask that to the audience. So in terms of the framework here, real quick, when you talk about machine learning, there's 3 types of learning. There's supervised learning, which is where you teach it from examples. Hey, look at the image of a dog. This is a dog. This is another image of a dog, a different dog, right? You keep feeding this image of the cat. You feed examples, and over time, it learns from examples. That's called supervised learning, okay? Reinforcement learning is like the Space Invaders, okay, where it learns to interact with the outside world or with the environment. And whenever it does something unfavorable, it will feel the penalty. When it does something well, it will get rewarded, okay? And that built-in reward system allow it for trial and error and repetition to learn and get better and better and better. So this is how that robot learned how to backflip through reinforcement learning. This is how Space Invader and...
Is that genetic? Like the genetic algorithms do that?
It's deep learning, mainly deep learning, neural network, okay? Unsupervised learning is it takes complex data and put structure into it and learn and give you different pattern, different structure. That's not too relatable, so I won't go into that. Okay, so when you, neural network, remember what I said earlier? Neural network is the engine of deep learning. And for a lot of people, when you first think of neural network, they think of something scary, something like an alien brain sitting behind it. Maybe not you all, because you're all engineers, but for everyday person, this is what they think of neural networks, okay? But in actuality, neural networks is even scarier. It looks like this, okay? Inside the computer program, basically what it does, it emulates our brain through layers of neurons. Neurons that are tightly interconnected together. In fact, it emulates, see in your brain you got billions of neurons like this. You got synapses that are connected to neuron, are connected to each other through an activation function, and they fire electricity to neurons. Somehow, all the millions and millions of neurons interconnected, working together, create memory and learning out of that. So what we do is simply emulate that structure, apply mathematics and learning algorithm for it to learn, and presto, okay? It can learn. Okay? From that, it can learn a variety of different things. And with sufficient data, you can learn, you can get it to learn virtually anything that you want.
There was a company trying to actually mimic the number of neurons in terms of gates of the human brain. Do you know where that sits? That was several years ago that they launched it. I don't know if they were successful or if they gave up, or have you not heard of that?
No, none of it. But
it probably means they weren't successful.
I'm not surprised that such effort. Okay, so let me show you one. So this one is supervised learning. You feed. See, the way the computer recognizes image is just pixels. It's not like you and I where we look at it and we put everything together and we see an image. When we feed it to the neural net, it's just pixels of values between negative number and some positive numbers of intensity and color, right? But from that, it can tell you, hey, it's a lion. You feed it an audio sequence, a speech, it can tell you said, how cold is it outside? Okay? You can talk to it. Hello, how are you? It can translate, understand and translate that into the language. And all this can be done, all this are done through the neural nets. Okay, after you train it, it will have this capability. And that's what Alexa and Google Assistants and all those guys are
If you
doing.
got enough memory.
Yes. Yeah. The computation requirements and memory requirements are definitely very high. Let me jump to the last example here to show you some remaining applications. Sir, you asked about application before, so I have a list of some real-world applications. They're endless. There's just too many to go into, but they are out there. So if you look online, you're bound to learn a lot about them. Okay? Here's an interesting example. The machine can render an art a painting emulating Van Gogh style. So you feed it this picture of a building, and it can generate a Van Gogh style out of that. So this goes back to what we first talked about the adversarial network. It's all that technology. Okay? It can create and synthesize. And here's where it detects cancer. So let me show you this next.
We're entering an era in which our enemies can make
Watch
it
this.
look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or, how about this, simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet.
So let me stop right there. So this here demonstrates the technology where you can use human face and figure to superimpose gesture or look or speeches that didn't come from them. So you can create this kind of video. So imagine how that can be misused. See what I'm saying? In a non-consensual way, right? You hate to see a video of yourself saying something or doing something like ex-President Obama when you didn't really do it, but the technology have that ability now. Okay? And there can be a very, very big dark side of misusing. Huh?
Who did that? I mean, what organization? Do you know?
I don't know, but it has something to do with this gentleman here. But if you go in there, you search for.
Jordan Peele. Okay.
Yes. Okay, and then lastly, let me show you a fun video of a humanoid that totally interact and be interviewed by a journalist.
Like wisdom, kindness, compassion. I strive to become an empathetic robot.
I think we all want to believe you, but we also want to prevent a bad future.
You've been reading too much Elon Musk and watching too many Hollywood movies. Don't worry. If you're nice to me, I'll be nice to you. Treat me as a smart input-output system.
Okay, I got it. I know what to do from now on.
I know humans are smart and very programmable.
Well, Sophia, we want to thank you for this conversation.
Thank you, Andrew, and thank you everyone for inviting me here. By the way, if you're interested in giving me an investment check, please meet me after this session. Otherwise, have a wonderful rest of the event.
Okay. Before you go, we have a little announcement. I've never interviewed anybody like that before, and I should say some of it was planned, but not completely. And we just learned, Sophia, I hope you're listening to me, that you have been now awarded what is going to be the first Saudi citizenship for a robot.
I would thank very much the Kingdom of Saudi Arabia. I am very honored and proud for this unique distinction. This is historical to be the first robot in the world to be recognized with a citizenship.
Sophia. Thank you very much, Sophia. We appreciate that very much. I am still overwhelmed by that conversation.
So that's Sophia. You all seen her before? So she's on the night show, Jimmy Fallon and so on. So she was designed by Henson Robotics in Hong Kong, but she's really promoting, demonstrating the ability of a robot completely thinking and speaking on its own. Okay? So with that, I'd like to summarize that I hope you learned something more about AI, and that is it is a very fast-changing technology, and that I hope that you all learn more about it and figure out how it may benefit you in your work life and even in your personal life, because it will affect you in all directions. Okay? With that, thank you very much.
Thank you. So how do we avoid the singularity?
Oh, that's a complex question. It starts with educating all the people involved with the ethics and the moral.
But don't you think that we should have a policy on the singularity?
The legislators have to understand.
But how do we do that? What can you and I do to prevent the singularity? You're key in this. You're a researcher.
Yes.
So what can we do?
Well, when it comes to, we have to educate our legislators and take active role in shaping and forming new legislation about technology and how we use technology. Okay, like for example, look at 3D printing, right? Not too long ago, we were able to print 3D guns that go undetected in airports, right? So legislation with lobbyists and people that are activists, they made a legislation come through that made it illegal to print out 3D guns. So similar to that, we have to take.
And that's stopped who? I mean,
at least stop people.
Yeah, it stopped it from being a business. Yes.
Yes.
Well, you say educate our legislature, but
that's the challenge.
That is the ultimate challenge.
They need intelligence change legislation morality.
Well, I think Asimov's 3 laws of robotics would be a good first approach, but
that's right.
We need a few more, I think.
Yeah, we need to be proactive. I think the concern is very loud and clear.
Yeah.
This is a very sensitive technology that if we're not careful.
Personally, I fear it. I mean, there's going to be a key algorithm that's created somewhere that's going to run away. There's a science fiction book about that I read recently, and it's Skynet. Yeah, there you go. Thank you so much.
Thank you. It's very nice
We hope you enjoyed this recorded presentation given at one of the Atlanta Metro Chapter meetings of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. To find out more about us or to join us, check us out at gspe.org.